start with the topic, that is A-star algorithm. Okay, so I hope you are clear with the concept of this one. Okay, A-star algorithm. Or anybody still having doubt with the best first search algorithm? Because if you are having doubt with the best first search algorithm, we cannot move forward with the A-star algorithm. A-star algorithm is a slight modification with the best first search algorithm. Okay, I'll explain you with the help of 2 to 3 examples. If you still having any doubts, you can ask me in the main video. Concentrate on my screen where I'm sharing the example. You are able to see the screen. Okay, we are starting with the example of 8 puzzle problem, and we need to solve 8 puzzle problem using A-star algorithm. Now what you need to do over here is that in A-star algorithm, we were considering f of n is equals to h of n. That means we were considering only heuristic function cost. Here we are making a slight modification to calculate the function cost. We are calculating like this: f of n is equal to g of n plus h of n. G of n, as you can see on the screen, G of n, see, for this problem it is a level of search, but in general it is a computational cost. What it takes to me to move from one step in my algorithm to the another step in my algorithm, that is G. So G of n, स्क्रीन ऑन करनी है और वॉइस मेरा ही बाउंस बैक होगा, आपका वॉइस तो इधर म्यूट कर इधर सुनाई देगा ना, तो कर दो ऑन, पीछे स्विच है. So here G of n is a computational cost. This is a generalized statement. Okay, for every problem G of n would be different thing. Okay, so let's take example that if you want to go from one destination to another destination, okay, searching the destination is another thing, but suppose you want to go from one location, you will either walk, you will either take auto rickshaw, taxi, or your own vehicle. So petrol cost or charges by the charges stated by the auto rickshaw driver, taxi, no? So that charges is considered as a computational cost. Reaching at the destination and finding the solution, that is a different thing. That is done by the heuristic function. So this is a very similar example to this. Okay? Now, here at first, see, we are going to find the solution of this particular 8 puzzle problem using A-star algorithm. Why A-star and why not best first search? The best first search will not guarantee you an optimal solution. There is a specific reason for writing A-star, the asterisk. Okay, why? Because asterisk tells us that this algorithm is admissible and it is definitely going to give you the optimal solution. Later on, we will discuss what is admissibility and optimal solution and all. But right now, for your understanding, just understand this, that it is better than any of other algorithms, as this algorithm gives you the optimal solution, the best solution. The rest of the algorithm doesn't guarantees you to give the optimal solution. It claims that we are going to give you the optimal solution. But this algorithm guarantees that you are going to get is the optimal solution. And that is why A-star is more popular than other algorithms. So let's start with the initial state. You can see the initial state and the goal state. So we have to start our journey from the initial state and reach at the goal state. The initial state is marked with 1 and the goal state is marked with 7. Heuristic function you know of the 8 puzzle problem. How you do it is with the help of H. Just a second. HDMI choose करो. The first system needs to be on. ठीक है माइक्रोसॉफ्ट टीम अब इसमें ओपन करो हाँ तो ब्राउजर से ही आप ओपन करोगे ना जस्ट अ सेकंड स्टूडेंट्स अगर आपके पास ब्लूटूथ हेडफोन्स या एयरडोप्स है तो फिर ये सिस्टम में ब्लूटूथ ऑन करके कनेक्ट करके सुनो मेरा वॉइस बाउंस बैक नहीं होना चाहिए सो वी आर स्टार्टिंग विथ इनिशियल स्टेट द स्कोर ऑफ इनिशियल स्टेट इज 4 see at initial state you can see g of n is equals to 0 so the heuristic function value is 4 that means 4 slides numbered tiles are not placed in the position as they are meant to be. So for initial state, always the level of search or the computational cost will be 0. As you move from the initial state, the computational cost might change. If in exam it is mentioned that consider the computational cost as this, then you have to consider that specific numeric values. Otherwise, add increment 1 for each step. That is the default values. So for state 1 or state A, your f of A is equals to 4. Now there are 3 possible moves available with us. B, C and D. B, C and D, these 3 are possible moves. Here, in best first search, what we used to select, the one with the minimum f function value. Okay, so here the function value is calculated 5 plus 1 that is equals to 6. See 1 plus 1 is for g of n. 3 plus 1 is equals to 4 and 5 plus 1 is equals to 6 for state D. That is how it is calculated. So 6, 4, 6. The value which is looking most promising to me at this moment is f of c. That is 4. Okay. So I am exploring this particular node with the value f of c is equals to 4 because out of this 3 this is the minimum value. So we have to select a node which is of minimum value. Exploring this we have E, F and G. So E we have 5, F we have 5 and G we have 6. Okay. When there is a tiebreaker, which node you should explore first? You can consider first come first serve to break the tie. Okay, so alphabetically E come first. That is why we have explored E. So 6, 7. Still you have not discarded F. So state H, state I, state F, state G. Out of this, which looks most promising? H, I, F, G. I think F looks most promising with the function value 5. Okay, this function value 5 is a combination of G plus H. So 2 plus 3, that is out. 2 is the computational cost, that is G of n. Exploring F. Okay, when you explore F, you land with the state J and K. Out of J and K, J looks most promising with the value 5. The heuristic function value would be 2 and the computational cost is 3. Then explore J. We have state I. Okay. Now, this is the only possible move over here. Exploring state I, two possible moves, out of which one is the goal state and the other one is the not goal state. So we have reached our goal state. A-star algorithm here promises you to get the optimal solution. So within 4 steps, as mentioned, f of a is equals to 4. Within 4 steps, you are able to get your solution. Okay. I'll explain you with one more example. Just wait for it. This is very important. Okay. Sometimes in exam, I ask you this kind of question. Here a graph is shown to you and you are asked to find the shortest path from A to Z. And the values in orange represent heuristic values, while the values in black represents computational cost, that is G of n. So G of n is represented by black values and H of n is represented by orange values. So you will be asked such kind of question that solve this problem, find the shortest distance with the help of A-star search algorithm. Okay. So what we are going to do? We are going to start with node A. We are going to start with the root node A. Computational cost at the root node will be 0. G of n for A would be 0. Heuristic function cost, it is 14. So f of n, that is equals to 14 for node A. Okay, that you can see over here. So we are starting with A. You need to maintain such kind of table also. Okay, so we are starting with A. Your shortest distance from A, that is computational cost G of n. Heuristic distance to Z, that is the H of n. And total distance is equals to f of n. So you need to assume that shortest distance from A is G of n. Heuristic distance from Z, that is H of n. And total distance, it is equal to f of n. So for a root node, always the computational cost will be 0. Heuristic function cost is mentioned in orange, that is 14. So for the total distance, G plus H, that is equals to 40. Okay. Next step, explore the neighbors of A, B and C. So you will explore the path A to B and A to C. The path A to B will cost you 4 plus 12. 4 is the computational cost and 12 is the heuristic function cost. So path from A to B will cost you 4 plus 12 is equals to 16. 4 is the computational cost. G of n is equals to 4. H of n is equals to 12. F of n would be 16. The path from A to C will cost you 14. G of n is equals to 3 and F of n, H of n is equals to 11. So 3 plus 11 you will get 14. This is how it will work. So you will explore path A to B and A to C. The computational cost 4 and 3, it is mentioned in the table. The heuristic cost is also mentioned 12 and 11. Add it 4 plus 12, 16 and 3 plus 11, 14. At this moment, node C looks most promising to me. Because in my table, I have the value 14, 16, 14. The value 14 looks most promising to me at this particular moment. So I will explore this node C. A I cannot explore because A is already visited. After visiting A, only we get this path B and C. Now we are exploring this node C because A was previously visited by us. Okay. So neighbors of C are E and D. Neighbors of C are E and D. So you will calculate the path 3 plus 10, that is equals to 13. The path ACE will cost you 13 plus 4, and path ACD will cost you 3 plus 7 plus 6. Okay, that is how it is calculated. So 3 plus 7 is equals to 10 plus 6, 16 for node D. The path ACD will cost us 16, and the path ACE will cost us 70. 3 plus 10 plus 4. Okay, so now looking at the values in total distance table. Okay, I have 14, 16, 14, 16, 17. Both the 14 values are visited. Now I have 16, 16. There is a tie. Which node I should explore, B or D? We will explore B because when there is a tie, we use first come first serve as a tiebreaker, and B comes alphabetically first. That is how we consider. So we'll explore B over here at this moment. Okay. So when you will explore B, you will explore all its neighbor F and E. Now the path cost will be ABF and ABE. So 4 plus 5 plus 11 for F, and 4 plus 12 plus 4 for node E. Okay, but we are not considering that. See, why we are not considering the cost? Because previously when we calculated, okay, the path ACE, it was costing me 13. Now if I consider this path ABE, what it is costing me? 2 plus 4, it is costing me 16. So I will obviously discard this path. Previously A, that is 3 plus 10, 13. To reach to E from A, it was costing me 3 plus 10. That is equals to 13. So in the table we can see the value is 13. Shortest distance from A is 13 for node E. But now if I consider this path ABE, the value is costing me 16. I won't consider that. So I will discard that part basically. For now, for next thing what I will do over here, for F I will place the value because F was not visited by us previously. So 4 plus 5 plus 11, we get 20. We are discarding this path ABE क्योंकि last जो previous path था वो better था with the value 13, वो cost कम कर रहा था, और अभी ये नया पार्ट जो आ रहा है ABE, वो उसका कॉस्टिंग 16 है, तो हम लोग उसको इग्नोर करते हैं, वो पार्ट कंसीडर ही नहीं करते. ठीक है, क्योंकि अगर वैल्यू कम हो तो टेबल में अपडेट करेंगे, अगर वैल्यू ज्यादा हो तो टेबल में अपडेट नहीं करेंगे. ठीक है, सो path from ACE is considered because previously it was costing us 13, and now if we consider this path ABE, it is costing us 16. So अगर last value से हमारी value कम हो, if this path ABE was costing us 12, 11 or 10, then we would have considered. But if this is costing us 16, the value greater than 13, the previous value, we are discarding it. तो आप उसका parent change नहीं करोगे, यहाँ पे C का parent change करना पड़ता, सॉरी E का parent change करना पड़ता. अभी E के parent में previous node C बोल रहा है, लेकिन अगर मैं path A B E वाला कंसिडर करूँ जो कम कॉस्ट का हो, तो फिर मुझे parent B लिखना पड़ेगा. ठीक है, आगे this path we are discarding. Looking at the table 14, 16, 14, 16, 17 and 20. Node D looks most promising to us at this particular moment. Looking at the values in the column total distance, node D looks most promising to me, and we are exploring node D. So you are exploring node D. Okay, so node D is explored. Now node D, consider the value of computational cost 3 plus 7 plus 2. The path is A, C, D. So 3 plus 7, that will cost you 10, plus 2, D to E, that will cost you 12. Okay, so now we are changing the previous node of, previously the previous node of E was C, but now it is D. Why? Because this value is less than 30. Previously, if you explore this path A, C, E, it is going to cost you 13. But if you explore this path A, C, D, it is going to cost you 12. So 12 is less than 13, so we are updating the value, updating the table. Okay, so we get the value over here is equals to 16, and previous node we are updating it with D. Now looking at the table, only node E is the one looks most promising and not visited. So let's visit node E. So when you visit node E, you have neighbor Z, and Z is what is your goal state, because the heuristic function value to Z is 0, and we terminate our search when we have heuristic function value that is equals to 0. Okay, let's do one more example. See, I'll ask you people to do it. See, you need to find shortest path from B to J using A-star algorithm. You have 15 minutes for finding it. Shortest path from, okay, consider from A to J. Let's make it more complex. Shortest path from A to J. See, at J, heuristic function value is not given. That is means that it is a goal state. Observe the node where the heuristic function value is not given. Okay, that is the goal state. Heuristic function value for the node is not given, that is goal state. Here in red you have heuristic function cost, and in brown you have computational cost. So find me shortest path from A to J using A-star algorithm. We are starting with A. For A, f of n, that is equals to g of n plus h of n. G of n is equals to 0. Heuristic function cost is 10. So for A, it will be f of n is equals to 10. Then you will explore the path A to B, and another path is A to F. So A to B path will cost you 6 plus 8, that is equals to 14 for the path A to B, and A to F, that is going to cost you 3 plus 6 equals to 9. 3 is the computational cost, 6 is the heuristic cost. Okay, first step I have already given you. A to B and A to F. A to F looks most promising. You should explore A to F at this moment. A, F, G, I. और एक स्टेप किया, दिखाओ तो ऐसी कैलकुलेशन ना, तो फिर वो वैलिड नहीं है, वो प्रूफ के तौर पे कंसिडर नहीं होगा. एक मिनट मैं कैलकुलेट कर लूं। मैंने प्रीवियसली दूसरे लेक्चर में ना बच्चों को पाथ दिया था बी टू जे का फाइंड करने के लिए। ठीक है, मैं देख लेती हूँ कितना हो रहा है। ए एफ जी का कॉस्ट होता है आपका 3+1 और एच ऑफ एन जी पे है 5। ए एफ जी आई जे, उसमें एफ ऑफ एन क्या लिखा आपने? जी ऑफ एन प्लस एच ऑफ एन। जी ऑफ एन आपका होगा 3+1 + 3+3 एंड ह्यूरिस्टिक फंक्शन 0, तो आपका ओवरऑल कॉस्ट कितना आएगा? 10 ना, वो शॉर्टेस्ट पाथ है। ए एफ जी आई जे। एक कॉम्प्लिकेटेड पाथ देती हूँ, चलो। ओके, उसमें जे का ह्यूरिस्टिक फंक्शन कॉस्ट आप अज्यूम करना 2। फाइंड शॉर्टेस्ट पाथ फ्रॉम बी टू आई। नहीं नहीं, बी टू आई भी बहुत शॉर्टेस्ट है। बी टू एच करो, चलो। जे के ऊपर कॉस्ट नहीं है ना ह्यूरिस्टिक फंक्शन, उसको 2 एज्यूम कर लो। तो शॉर्टेस्ट पाथ फ्रॉम बी टू एच यूजिंग ए स्टार एल्गोरिथम। बी टू एच जाना है आपको, होल इनिशियल नोड बी। BCEIH, हाँ वो सही बात है। ओके, B पे तो कॉस्ट होगा हमारा 8. Then we will explore path B to C and B to A. B to C path is going to cost you 8 and B to A path cost you 16. So definitely we will go for B to C. So B to C, now you will explore this path B, C, D, and you will explore also B, C, E, because neighbors of C are D and E also. Okay. Also, we forgot to, in the first step, you will be having path B to D also, which is 2 plus 7, that is equals to 9. Okay. So at this moment, path B to C looks most promising. So now you will explore this path B, C, D. B, C, D will cost you 11 and B, C, E is also going to cost you 11. Tiebreaker, alphabetically D comes first, so explore D. Okay, first come, first serve. So we are exploring this path B, C, D, E. B, C, D, E is costing me 15. Okay, discarded because we have B, C, E, which is costing us 11. So we are exploring this path B, C, E, D. So B, C, E, D, it is 23, discarded. Now explore this path B, C, E, I. This is giving me value 14, which is looking promising. And then we have, which is giving me value 18. So 14, and also we will go for 14. That means this path B, C, E, I. Then B, C, E, I. Next node is H. H is our goal state. The heuristic function will be 0 over there. So the shortest path to reach from B to H is B, C, E, I, H. This is the way. Any queries for the A-star algorithm? Any queries for the A-star algorithm? In a, you have to draw the table for each step, or you can calculate f of n is equals to g of n plus h of n for each step. Table is very easy. If you maintain the table, you don't have to show each and every step for calculation. Just show the cancel out values so we can understand that you have traced it out. Okay. तब आप मोबाइल में बिजी थे કેમ આટલી મોટી સ્ક્રીન ઓછી પડી તો આપણે મોબાઈલ માં નીચે જોવું પડ્યું બધું જ બહાના છે એવું તો દેખાયું નહીં બ્લેક સ્ક્રીન હતી નહીં સ્પીડ હોય તમને મીટિંગ માં કેટલી વાર છે અહીંયા જોઈન અને એક્ઝિટ લો છો ને બધું ખબર પડશે બતાવી દઉં છું બીજું શું this kind of table you have to. જે વિઝિટ જેને એક્સપ્લોર કરી લીધું છે જેની હ્યુરિસ્ટિક ફંક્શન વેલ્યુ કેલ્ક્યુલેટ થઈ ગઈ છે ટોટલ ડિસ્ટન્સ કેલ્ક્યુલેટ કર્યું છે અને વિઝિટેડ ફાઇનલ ટેબલ બનાવો તો ચાલી જાય પણ પછી બધા સ્ટેપ માટે તમારે પેલું કેલ્ક્યુલેશન તો બતાવવું જ પડે. f of n is equals to 0. એ ટેબલમાં ના બતાવો તો ચાલે, બાજુમાં રફ વર્ક તરીકે બતાવો. સી માર્ક્સ ખાલી સ્ટેપના છે આમાં. અરે એ આવી ગયા છે, ડિક્લેર કરવાના રહી ગયા છે. હું તમને શેર કરી દઉં પીડીએફ. ઓલમોસ્ટ બધાના 29 30. આમાં ક્યાં તમે પૂછો છો અમને? એમસીક્યુ જ હતા. તો પછી તમે લોકો 29 30 વાળા છે, એમાં ક્યાં વેરિયન્સ આવવાનું છે? હા, એ તો ઓન ધ સ્પોટ બધા જોઈ જ લીધા હતા ત્યારે. એમ ક્યાં તમારે નવાઈ હતી જ. હવે જોજો સેકન્ડમાં કે એ ટાઈમે તો સિલેબસ ચાલે જ શું હતો, ખાલી હાફ યુનિટ. હવે સિલેબસ ચાલે છે એટલે હવે મજા આવશે ને. એ સ્ટાર ડીએફએસ બધાના ક્વેશ્ચન પૂછાશે. હવે ક્વેશ્ચન પેપર વ્યવસ્થિત નીકળશે, કેમ કે હવે સિલેબસ મારી સાઈડથી બી ચાલી ગયો છે અને સરની સાઈડથી બી ચાલી ગયો છે. Any queries, students? Otherwise, you can enjoy your break. I'm terminating the meeting.